So in this video, I'm going to show you how to do the dollar-weighted return using the IRR function in Excel. So recall, I just cut and paste this example from the PowerPoint slides. You bought one share of the stock in year 0 for $50, so that's a $50 cash outflow. In the second year, the stock price went up to 53 and you received a $2 dividend, but you also bought an additional share of the stock. So here that's the negative 53 cash outflow plus the positive $2 dividend is where I got that negative 51 cash flow. Then in year 2, you decide to sell both shares of the stock where the share price is $54 after receiving $2 in dividends per share. So this is your positive share price times 2 shares plus your dividends times those 2 shares where you sell everything off. Now I have the cash flows in each year, and I'm going to use the IRR function to get the dollar-weighted return. So equals IRR, highlight these, close parenthesis, enter, and I get 7.12%. I can use my Scoochie function to get out all the way to the decimals as shown there. For the time-weighted return, as we talked about when we were doing the PowerPoint slides, you calculate the return in each year as the capital gains yield, so which is a capital gain or capital loss, right, plus that dividend. So any dividends received. So from year 0 to 1, your stock price went from $50 to $53 plus you received a $2 dividend scaled by that $50 initial price, so you had a 10% rate of return. This one you really can't solve using any special functions in Excel. I just realized that when I put it on the PowerPoint slides, I hadn't actually written out what the initial equation was. I had just shown you starting over here, or fully solving for G. But remember, we're plugging into the equation 1 plus RG to the N is equal to, and we evenly distribute all of our returns. So in this case, they are not the 5.66% return that we got in year 2, even though that's less than the 10% return we got in year 1, they're put on a level playing field. Versus when we used the IRR rate of return, it was recognizing the time value of money. It was recognizing the smaller jump in price in capital appreciation from year 1 to year 2 as versus year 0 to year 1. Right, so this is the first step, and then go solve algebraically for G, and you got 7.81%. So because that time-weighted return ironically ignores time value of money and treats all the returns equally, that's why you're seeing a higher rate of return there.